Good morning, good afternoon, good evening. My name is Adebayo Awonaike, and I'm presenting a machine learning approach to estimating UK house prices on behalf of my colleagues and I. The contribution that this paper adds to knowledge include an enrichment of the HM Land Registry price paid data, a modularized multi-parameter house price estimation framework, and a cumulative parameter layering approach. The enriched HM price registry data, as we see on screen, now comprises of a whole range of data sets. If you look at columns 3 and 6, comprise of a whole range of attributes from a whole range of other sources other than the primary data set, which is the price paid data. And I would explain this in detail later. The modularized framework here, according to Lavi and Rami in 2018, on their work, which focused on the propensity of beginner programmers to use modular programming. Experimentation was done with 2 study groups, finding that there is an application of minimal effort that is achieved is achieved through the modularization of applications. However, the modularity was not used by most students due to a lack of skill, laxity, or just the fear of starting all over again. Now, this paper has explored the modularization framework, comprising of 8 different models that ensures that the system, the framework that is being built here is as robust as possible and repeatable. The cumulative multi-parameter layering involves 2 different tiers, tier 1 and tier 2, where tier 1 comprises of the price paid data and the ONS price postcode data, and tier 2 is a combination of all of the tier 1 data, but now including the introduction of rail stations, supermarkets, and bus stops. The cumulative multi-parameter layering of groups here, groups of different data sets, is one of the primary focus of this piece of work. This paper has leveraged the design science research methodology. There are a number of research methods that have been explored, including experimental by Pak B and Bay, JK in 2014, comparative study by Madhuri et al. In 2019, systematic sampling by Rico Juan and Tileville La Paz in 2021. Now, since this research aims to explore a multi-parameter layering approach for the design of house price estimation framework, the design science research methodology is being explored. And over the next few minutes, I will simply be going through the 6 different stages from problem identification to definition of objectives, design and development, demonstration, evaluation, and how this work is being communicated. Problem definition. Now, a number of machine learning driven and multi-data enabled frameworks already exist today for the estimation of house prices. However, there is a lack of research to understand the potential impact of cumulative parameter layering on selected machine learning algorithms and their accuracy. design definition of objectives. And the objective for this paper is to evaluate the impact of cumulative multi-parameter on an ensemble of machine learning techniques used to estimate house prices. And in the third stage of the methodology, design and development, I'll be going into the details of the modeling, optimization, and evaluation. To go into the data sets that have been considered in the course of this paper at a very high level includes 10 different data sets as shown on screen. For more details, you may want to have a look at the paper that goes with this presentation. Just a quick dive to more like an expression data analysis. On screen, you can see the volume of transactions year on year between 2011 and 2020. And then this is the distribution of house transactions based on the types of duration, whether it's freehold or leasehold, a distribution of the volume of transactions based on the different house types. And then here you've got a distribution based on age. I will not be going into the details of the data preprocessing. However, after data preprocessing, what you see on screen is the final set of variables or parameters that are used in the modeling. The demonstration session, I go into the modeling. 5 different algorithms were considered, like GBM, random forest, XGBoost, hybrid regression, and stacked generalization. And these are being considered for different reasons based on their capabilities. On screen, you've got the baseline results for light GBM, looking at both tier 1 and the introduction of tier 2. Remember, tier 1 is just the price paid data and the ONS data, while tier 2 introduces rail stations, distance from rail stations, distance from bus stops, and distance from supermarkets. And this is a view of the baseline modeling for light GBM. Results for baseline modeling for random forest. And this here you also have the results of the baseline modeling for XGBoost, hybrid regression, and stacked generalization. And then I've explored Bayesian optimization for hyperparameter tuning. And what you'll see on screen is then the results for both for the optimization, but with a focus on hybrid regression, with a focus on light GBM, random forest, and XGBoost, owing to computational cost. What you see on screen is the explainability for the tier 1 and then followed by tier 2, but explainability here only purely showing the impact of specific variables in the models, and you will see the variation from tier 1 to tier 2. A quick dive into the evaluation because of the time I've got. I've used 3 different evaluation metrics, RMSE, MAE, and R-square. However, for the purpose of this presentation, focusing purely on RMSE, you will notice that for the RMSE results from tier 1 to tier 2, there is a reduction in the value of the RMSE model technique after model technique, though there is no change for XGBoost. However, for all the other techniques, there is a reduction showing an improvement in the accuracy. This slide then shows that for the baseline models, random forest has shown the most improvement from tier 1 to tier 2. And this validates the fact that an introduction of new variables in taking a cumulative approach improves the accuracy of the models. Then up to optimization, you would notice the similar trend, a reduction in the value of the RMSE score, and which shows improvement in the accuracy. And the comparison also shows a further improvement for random forest. And with that, able to make the conclusion that random forest performs better based on the introduction of additional parameters into the model. And finally, the last stage of the methodology is communication. And this piece of work is being communicated at the moment in the conference proceedings with the topic, a machine learning framework for house price estimation. If you've got any questions, please do not hesitate to make a connection. Thank you.